Today we're going to make the analysis of a rational function. This is a rational function. As first step, we're going to take the domain by taking the denominator and factorizing it. As we might see, we have a maximum common factor that is 2. And then we have a trinomial in here, so we shall factorize it. And we're going to equal this to 0. We're going to divide the whole equation by 2 so we can cancel this one. It will finish as x plus 2 squared equal to 0. Main, we have x plus 2 equal to 0, and that will be x equals to minus 2. The remain will be all real numbers except for minus 2. Previously, we get the roots of the denominator, and with that value that it was minus 2, we're going to substitute it in x. And we're going to solve this. The result for the whole equation in the denominator will be 0. And in the numerator will be minus 3. So if we have a number divided by 0, it means that we have a vertical asymptote. There is a vertical asymptote in the equation x equals to minus 2. If you remember, when we get to the domain, we factorize the denominator. And that is why we didn't use 2x squared plus 8x plus 8. We use the factorized form of this, that will be 2 times x plus 2 squared. Now, we need to get the behavior of the graph when it is after minus 2. And as I already said, we use the factorized form of the denominator. And we're going to substitute the minus 2. Also, in the denominator we get 0, so we're going to use another number that is greater than minus 2. In this case, it would be minus 1.9. Also, our principal goal is to get the signs. So this will equal to minus over plus, and this means that the behavior after minus 2 will go to minus infinite. The following step is to get the x-intercept. To get it, we're going to equal our whole equation to 0. To get this, at the end we're going to get the denominator times 0, so it will cancel. So we're going to equal only the denominator part, which would be minus 8x squared minus 32x minus 35 equal to 0. And then we're going to isolate this one. We can use the general formula. This is minus times minus will give you plus, and minus 3 to power to 2 would be 1024, and the result for this would be 1120 over minus 16, and this will equal to 32 plus minus square root of minus 96 over minus 16. As we may see here, we have a negative root. That means that it's an imaginary number, and if it's an imaginary number, it means that we have no roots because they never cross the x-axis. The next point we're going to get is the y-intercept, and to get it, we need to equal all the values of x to 0. These two values will equal to 0, so we're just going to write minus 35. And in the denominator, these two will equal to 0 too, so we're just going to write plus 8. And this would be 35, 8. And as a coordinate, it would be 0, minus 35 over 8. To get the range, let's remember that x approaches before minus 2, and that means that what it approaches to minus infinite, and when x approaches to after minus 2, it would go also, y will also go to minus infinite, and when x approaches to minus infinite, y would go to minus 4, and when x approaches to positive infinite, y would go also to minus 4. So this means that our range would be from negative infinite to negative 4. Now we're going to graph all the values that we get previous. The first value we're going to settle is the vertical asymptote, that is x equals to minus 2. So that means it would be on here. Our next value would be our horizontal asymptote, that is at y equals to minus 4. As we remember, on this function we don't have roots, so it won't cross the x-axis. Now we're going to put the value of the y-intercept, that is the coordinate is 0, minus 35, 8. That would be around here. Our next step is to graph the behavior. As we remember, both goes to minus infinite. So this will go from the vertical asymptote, and it would cross the y-intercept, and it would go to the horizontal asymptote, and in our other side would be the same. It would go from the vertical asymptote to the horizontal.